Hi, this video is on the unit circle. What I'm hoping you'll learn is how to sketch the unit circle, know what the definitions of sine, cos and tan are, know what the cast diagram is and what it's useful for, and the definition of tan in terms of sine and cos and the Pythagorean identity too. We're going to start by looking at the unit circle here. The unit circle is a circle with radius 1. So if we put it in the middle at 0, 0 here, that would give us coordinate points here of 1, 0, of 0, 1, of minus 1, 0, and of 0, minus 1 there. What we've got here, if we drop a line down here, drop a perpendicular down, we end up with a right angle triangle with an angle theta here. Now theta is going to be measured from the x-axis here, going in this direction, which is anti-clockwise, as we move a point here, P, which we can call XY, around the circle. So as we move that point around, this angle here changes and goes around in an anti-clockwise direction. Now, we're going to start by looking at sine. Now, so far, sine theta has been defined as the opposite over hypotenuse, or the ratio between the opposite side and the hypotenuse, in a right angle triangle. Now, that's still true here, but what we can do, because we have a hypotenuse that is length 1, because the radius is 1, is say that sine theta is also equal to the y value here, which is the height of this triangle, or the length of this side, divided by 1. So this side here is equal to y, which is the height, and because it's y divided by 1, y is equal to sine theta. So the height of that side is sine theta. That's that side there is sine theta. That's what sine theta is. The height of that triangle, or the y coordinate on the unit circle, which is what we've got there. So the height of the vertical line in the unit circle, or the y coordinate there. Okay. Now, as we move around, remember we're moving from this line going in an anti-clockwise direction. So if we move around a little bit further, say to over here, so theta becomes a larger angle there. We'd still have our right angle triangle, and sine theta would now be the height of this triangle, or the y coordinate there. If we keep going a little bit further, somewhere in this quadrant, we'd end up with another right angle triangle. So our angle this time is over 180, so maybe about 210, something like that. And the height, or sine theta, would be the height here of that triangle there, which is also the y coordinate here. So that is sine theta when we increase that angle. And if we came all the way around, if we came all the way around to somewhere in here, we'd end up with that being sine theta. Okay, so some immediate results that we can get. If the angle that we turn through is 0, so if we start here on the x-axis, flat on the x-axis, and then don't move, well, the height there is going to be 0, and you can see that the y coordinate is 0. So sine of 0 is equal to 0. Sine of pi over 2. Now, just a quick reminder, if we're starting here at 0, and if we go all the way around a circle, we end up at having travelled through 2 pi radians. That means half a circle would be pi radians. This would be pi over 2 radians, and this would be 1.5 radians, or 3 over 2 pi radians. So 1.5 pi radians, I mean. Okay, so pi over 2, if you notice that the y coordinate up here is going to be 1, and the height there is 1. sine of pi, if we go all the way around again, well, it's going to be flat again, and the y coordinate is going to be 0. So sine of pi is 0. Sine of 3 pi over 2 means we've come all the way around here, and you can see that the y coordinate there is going to be minus 1. And sine of 2 pi means we've come all the way around, and we're back to where we started again at sine 0. So that's back to 0 again. So those are some immediate results. We will look at others, but not right now. Something else I'd just like you to notice is the sign of sine theta, by which I mean is it positive or negative. And you'll notice that from here in this first quadrant it went from 0 up to 1, and the height there is going to be between 0 and 1 for any other angle in this first quadrant here. That's Q1, first quadrant here. And those are all positive. So sine theta is positive in quadrant 1. Now if we move over to quadrant 2 here, that's going here, sort of between 90 degrees and 180, or between pi over 2 and pi. And you'll notice here that still it's going to be between 1 at its maximum and 0 at its minimum, and all those other heights here, they're still going to be positive. So it's positive in quadrant 2. In quadrant 3, it drops below the x-axis, so you can see that the height is going to be negative from 0 all the way to minus 1. So it's negative here, and you should be able to see that as we carry around here, this height is going to be negative here as well. So the y coordinate is negative. So we've got positive, 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 negative, negative. Okay, now cosine. If we have a look at cosine here and label our diagram in the same way, so we've got a hypotenuse of 1, this is theta, it's a right angle triangle, and we have 1, 1, negative 1, negative 1, starting at 0 degrees and travelling in an anti-clockwise direction. Now, this time, with our point xy there, cos theta is adjacent over hypotenuse, which is, this is the adjacent side, so it's going to be, I'm sure you can see the x value, so it's x, because that side there is x, and because cos theta is x over 1, it means that cos theta equals x, so this length here is cos theta. That, the base of the triangle in the unit circle, is cos theta, which is also the x coordinate. Sorry. There we go. So, cos theta, rather, is the length of the horizontal line in the unit circle, or the x coordinate. Now, as we move around, we have the same sort of thing happening. So, if our angle went into the second quadrant, it would be the base here. That would be cos theta, and you'll notice that this time this is going to be negative because it's on the left hand side of the y-axis, so our x-coordinate is going to be negative. If we come round a bit further, there we go, still negative, and come round a bit further again, back into being positive again. So, similar to what we had before, some immediate results that we can get. Cos of 0 means the base of the triangle here, or the x-coordinate, when the angle is 0. So if we bring this line all the way back down to here, you can see that the line there, the base would be 1, the x-coordinate would be 1. So cos of 0 equals 1. Cos of pi over 2, as this comes all the way up here, well, we have a line going up there that has a height of 1, but the base is 0. It has no width or thickness there. So cos of pi over 2 would be 0. The x-coordinate, as you can see, is 0. Cos pi, if we come all the way around, so remember that was pi over 2, pi, 3 pi over 2 at the bottom there. So as we come around, here the base of the triangle is going to be minus 1. Cos 3 pi over 2 is going to be 0 again, and as we come back round here, we're back to where we started, so that's going to be 1. Okay, so we can see that in quadrant 1 we here, we're going to have cos theta is going to be positive. In quadrant 2 we could see it was negative. Quadrant 3 it's negative, and quadrant 4 it's back to being positive again. Okay, we'll have a quick look at tan now. Okay, now for tan theta, again, if we had our point there, point xy, we have our radius of 1, we now know that this is sine theta and this side is cos theta, and that's theta there. Well, tan theta is defined as the opposite side over the adjacent side in a right angle triangle. Okay, well the opposite side is sine theta and the adjacent side is cos theta. So tan theta is the y over the x, or sine theta over cos theta. Now, another way that we can look at tan is if we extend that line out there so it hits this tangent at 1, 0. This distance here, this height here, or the opposite side over that side, which was always going to be 1, is in the same ratio as sine theta over cos theta, so that's also tan theta. So another way of looking at tan theta is it's the height of that line, and as you vary theta, you can see it's going to keep going up and up and up and up, which is why tan theta doesn't have a limit in the same way as sine and cosine do. They never go above 1 or minus 1, but tan theta can keep growing off to infinity up here. So if we want to work out tan of 0, we can now do sine of 0 over cosine of 0, which we knew from our previous slides is 0 and 1. So 0 over 1 equals 0, and we can fill the rest of these in now as well. So tan of pi over 2 is sine of pi over 2 over cos pi over 2, tan pi, sine pi over cos pi, and so on. So some interesting results here now. We've got 0 over 1, which is 0, 0 over minus 1, which is 0, and 0 over 1, which is 0. But here, 1 over 0, we can't divide by 0, so this is undefined, and this is undefined. Now this makes sense if you have a look at what this means in terms of the height on that line. As theta becomes pi, or 90 degrees, you end up with a line that goes straight up there. This line is going to be parallel to that line, is never going to touch it. So there is no point at which that line is going to intersect with that line. So there is no tangent value. There is no number that we can associate with tan of 90. In terms of being positive or negative, in the first quadrant here, you're going to get a positive value here. As soon as it goes over here into the second quadrant, you're going to get a negative value. So we've got positive, negative. When the angle comes round here again, you can see that that is going to be positive again, and as it comes round to here in the fourth quadrant, you're going to get crossing in a negative place again, so negative. So it's positive, negative, positive, negative. Now we can summarize all of that positive, negative information into a single diagram. All of the functions were positive in the first quadrant. Sine was the only one that was positive in the second quadrant. Tan was the only one that was positive in the third quadrant, and cosine was the only one that was positive in the fourth quadrant. So this is called a cast diagram, and it just helps you decide when the various different functions are positive or negative. Quick note on the Pythagorean identity. Again, if we have our point P now, x and y we know can be replaced by sine theta and cos theta. So if x squared plus y squared equaled 1 squared, we could also say that sine theta squared plus cos theta squared equals 1 squared, or sine squared theta plus cos squared theta, which is how we write this, equals 1. And we'll come back to use that another time. Okay, quick. Sine theta and cos theta are defined as the height and the length of the base in that angle, or the x value and the y value. Tan theta is the height as it hits that tangent there, and tan theta is defined as sine theta over cosine theta.